Simple English. Part 1. What is a buffer? A buffer is just a small memory space used to store data temporarily. Think of it like a bucket. If bucket size equals 5 liters and you pour 10 liters, water spills out. That overflow equals buffer overflow. Part 2. What is buffer overflow in computer? In programming, especially C, C++, a program creates a fixed size memory space. Example, you can see the code in our conversation history. This means only 10 characters allowed. If someone enters, you can see the code in our conversation history, 20 characters. It will overflow into nearby memory. Why this is dangerous? Because nearby memory may contain passwords, program instructions, security checks, return addresses. If attacker overwrites those, they can crash the program, run their own code, take control of system. Part 3, very simple code example, unsafe C code. You can see the code in our conversation history. Problem, gets does not check length. If user inputs 50 characters, memory corruption. Nash, what happens internally? Memory layout example, you can see the code in our conversation history. If attacker overflows buffer, they can overwrite. You can see the code in our conversation history and control where program jumps next. This can lead to remote code execution. Part 4, real-world example 1. Morris worm, 1988, one of the first major internet worms. It exploited buffer overflow in Unix systems. It used overflow in a service called sendmail. Attackers sent specially crafted long input. System crashed and spread worm across internet. Impact, 10% of internet affected. Massive disruption. Real-world example 2. Code Red Worm 2001 exploited buffer overflow in Microsoft iOS vulnerable component indexing service. Attacker sent long malicious HTTP request. Buffer overflow allowed. Remote code execution, website defacement, DDoS attacks. Impact, infected 350,000 plus servers, huge financial damage. Attacker Part 6, Real-World Example 3. WannaCry ransomware, indirectly related to memory exploit. Used vulnerability in Microsoft Windows, specifically SMB protocol overflow, Eternal Blue exploit. Attacker sent specially crafted network packets. Buffer overflow allowed, remote code execution, file encryption, global ransomware spread. Impact, 150 plus countries, hospitals affected, billions in losses. Nutter Part 7, why buffer overflow happens, mostly in C, C++, low-level languages, because they do not automatically check memory size, give direct memory access. Languages like Java, Python are safer because they handle memory automatically. NAR Part 8, types of buffer overflow stack, overflow, heap overflow, integer overflow related concept. Most classic attacks target stack-based overflow. NAR Part 9, why it is very dangerous because it can lead to remote code execution, RCE, privilege escalation, system takeover, worm spreading, ransomware. It is considered critical severity. Part 10, how developers prevent it. Use safe functions, fgets instead of gets, input validation, use modern languages, stack canaries ASLR, address space layout randomization, deep data execution prevention. Modern OS protections make it harder but still possible if misconfigured. Tashhef final simple understanding buffer overflow equals when program memory space is smaller than input and extra data overwrites nearby memory, leading to crash or code execution. Real-world damage examples, Morris worm, Code Red worm, WannaCry exploitation chain. If you want next, visual memory diagram explanation, how hackers exploit it step by step, conceptual only, difference between stack and heap overflow, modern protections explained simply, tell me what level you want next.